All right, today we are going to do our EOC review 4 on statistics. These are the questions that we are going to answer in this video. The first one, how can you collect, organize, and display data? Okay, to collect data, you're going to collect data, or you could collect data through surveys. Okay, you could do it through surveys, observations, polls. Okay, there are so many different ways to collect information from people. Forms, Google Forms, so many different ways that you can collect information from people. That's so very important that you do that. And they collect this thing called census every 10 years. I know you've heard of that, where there is basically a survey of how many people live in your house and, just all different kinds of information. And they do that for supply and demand, for voting, for all kinds of reasons why they collect information from you. Okay. How do you organize that information that you collect? To organize that information that you collect, you might put it in a table or in a chart. Okay, just so you can visually see it. You might put it in different categories. Okay, you need to visually be able to organize that information that you have collected. And to do that, sometimes they put them in different tables, charts, categories. How do you display that? Depending on the question that you want to answer, you display it through graphs and some special tables too, okay? Frequency tables and things like that. But if it was and we'll do some examples, we'll talk about some examples like a bar graph, okay? A bar graph displays the frequency of how many people or how many things fit into a particular category. Like, for instance, favorite foods. How many people like pizza? Or how many people like spaghetti? So you have your categories along the bottom. You have your categories here. You might have foods. And then along the side, you're going to have number of. And then you can display that in a bar graph. You have your circle graphs. Now, your circle graphs will tell you the percentages. 50% of the people might like something versus something else, okay? Or even if we're talking about food, 50% of the people like pizza and maybe 25% like tacos or something else. So your circle graph displays the percentages. Maybe you want to know what the percentages are. All right. So we got frequency of a category here. You got percentages here. And then you have what you call a line graph. And I'm going to just do a couple examples. I'm not going to do them all because there's so many graphs out there. A line graph will tell you change over a period of time. Okay. This is change over time. So you can easily see this is time displayed on the bottom. You see how the changes, it displays the change over a period of time. That's what a line graph does. Then you have a scatter plot, which you talked about earlier in the year. Scatter plots compare quantities. Okay, quantities are numbers. You might have age here, and you might have height along the side here, and this person's age is this height, and this person's age is this height, and you got this person's age is another height, and it basically is comparing two quantities, age and height. That's what scatter plots do. So depending on what question you're trying to answer or display, that's going to be the graph that you're going to use for the information that you have collected and organized. A histogram. Histograms are comparisons of two variables or quantities. Okay, so a histogram looks like this, very similar to a scatter plot, but it looks like a bar graph. Okay, so for a histogram, you may have heights here, and you might have the number of trees along the side, number of trees. And so then you have your heights along the bottom, and you have the number of trees along the side. So maybe this particular height, there's only one or two trees that display this height, and maybe a few more trees are in this range for height, and you got a few more that are this height. You don't have hardly any trees that are this particular height, and so on and so forth. Okay, so a histogram is a comparison of two quantities. This is a quantity. Height is a number of some sort, and trees, of course, the number of trees that's displayed as a number. Okay. Graphs. We got another type of graph, which is a line plot. With a line plot, you use a number line, of course, where your X on a number line to describe the frequency. That's how many. Okay, so you might have ages here. You have different people's ages here, and it's the ages of people, and maybe how many ages there are within this class. So you might have people 12, 13, 14, 15, even 16. Okay, so maybe you have this many people that are 13 in the class, about the same number that are 14, a couple people or a few people that are 15, one person that's 16, and you have a couple people that are 12. This is a line plot. Frequency is how many. So how many people are this age? Okay, how many people are this age? All right. Another kind of plot is a dot plot. This is where you use dots for the frequency instead of the x's. So we could do the same thing, but this time we using dots instead. So we got our ages here, and we still have 12, 13, 14, 15, and 16. And you have a couple people that are 12. You have a few more of those people that are 13. You have some that are 14, and some that are 15, and one person that is 16. This is what a dot plot looks like. Okay, they are the same thing, just one uses X's and the other one uses dots. Okay, the other type of graph that we're going to talk about is a box and whisker plot. And again, this is one that has a number line, but it displays your 5-number summary. Okay, we're going to talk about what that 5-number summary is. So we have our number line. We have maybe 5, 6, 7, 8, 9, 10, 11, 12, 13. So we might have a list of numbers, and from that list of numbers, we find what you call the 5-number summary. The first 5-number summary is your lower extreme. Your lower extreme is going to be the smallest number in that list. So let's suppose that our smallest number in the list is 6. So we're going to put a dot above 6. Okay? All right, and while I'm at that, this 5-number summary, that's the next little page. We can go ahead and write that definition in. Your lower extreme for your 5-number summary, in the calculator, you will see that it's min x. Okay, so that's why I have that in parentheses. But the definition of the lower extreme is the smallest number in the list, or the lowest number in the list. Okay. All right. So you put a dot. This is your lower extreme. I'm gonna put LE under it, okay? Lower extreme. Then the next number that you find is going to be the middle number. More than likely, the middle number is the number that's in the middle. You're gonna find the middle number, and let's suppose that our middle number is 9. This is our median, MED, okay? And your middle number is the number that's in the middle. Okay. The number that's in, okay. So your number that's in the middle number. So find the number that's in the middle. That's going to be your median. Then after you find what your median is, sorry. Lost my page. Then you're going to find your number that's between the halfway mark between, or the middle number between the lower extreme and the median. So in your list, whatever number falls in the middle between these two numbers, whichever one falls in the middle, that's going to be your lower, and I probably should label it afterwards. That's going to be your lower quartile, okay? So your lower quartile is going to be the number that is in the middle between the lower extreme and the median. The number in the middle, and it's between, I'm going to abbreviate between the lower extreme and median. So it's the numbers right in the middle between these two numbers right here. Okay. And the abbreviation in the calculator for lower quartile is Q1. The abbreviation for median in the calculator is MED. All right. Okay. So now we're going to find the highest number in the list. So your highest number in the list, let's suppose that it is right here. It's 12. Let's suppose that's the highest number in the list. Okay. So the highest number in the list. Okay. There we go. And the last value that you find is the number that's directly between the median and the highest number in the list, which is the upper extreme. So the number that's in the middle, when you find that middle number in your list between the median and the highest number in the list, or the upper extreme, that's going to be your upper quartile. So your upper quartile is the number in the middle between median and upper extreme. All right. So this is what the visual looks like. You're going to put boxes around the quartiles. These are your quartiles. Draw a line through the middle number. Okay. And then from this side of the box, which is your lower extreme, your lower quartile to your lower extreme, and from your upper quartile to your upper extreme, you draw what you call like the whiskers, the little lines. Okay, so this is your box and whisker. So again, this is your lower extreme. This is your lower quartile. This is your middle number. This is your upper quartile. This is your upper extreme. Okay, and those are your values there. All right. So now let's talk about the percentages of those quartiles. Okay. So now we have. I'm gonna just draw a regular box and whisker. Okay. Draw a number line under it. All right. So your box and whisker is broken into 4 quartiles. This is quartile number 1. This is quartile number 2. This is quartile number 3. And from here to here, this is quartile number 4. So this is quartile 1. This is quartile 2, quartile 3, and quartile 4. Okay. And again, this is your lower extreme. This is your lower quartile. This is your median. This is your upper quartile. And this is your upper extreme. Okay. Now the percentiles, if the number is, well, your lower quartile here is the 25th percentile. It's 25%. It's in the 25th percent range. This is your first quartile. Remember, think of quarters. It's in the first quarter. It's the 25th percentile. So whatever this number is right here, this is the 25th percentile. Anything that's under that is under the 25th percentile. If I want to find the 10th percentile, I would look somewhere in here. Okay? The halfway mark, the median, is the number that's in the 50th percentile. Okay? It's the 50th percentile. The number that's right here, the upper quartile, is in the 75th percentile. It's in the 75th percentile. All right? If I want to find a number that's in the 40th percentile, I would look in quartile 2. If I want to find a number that's in the 60th percentile, I would look in quartile 3. If I wanted to find a number that was in the 90th percentile, I would look in quartile number 4. Okay? So whatever number is the upper extreme, the upper quartile, is the 75th percentile. The median, whatever number that is the 50th percentile. Whatever number the lower quartile is the 25th percentile. Okay? All right. So now we're talking about distributions. Okay. So we're going in now and talk about distribution. Distribution, it displays the spread of numbers. So a distribution displays the spread of numbers. Okay, how those numbers are spread out. And in most cases, they use either they can use a histogram or a line plot or a dot plot, because that shows the shape of a distribution. Okay, it shows the spread of numbers. So let's use a line plot. Okay, so a normal distribution looks like this. A normal distribution, they refer to it as a bell curve. I don't know if you've ever heard of a bell curve before, but a normal distribution, and I'll display it in different ways. A normal distribution, let's start with the line plot. This is a normal distribution like this. Okay, it's very symmetrical. And sometimes you'll hear them say the word, or you'll see the word symmetrical. Okay, because most of the numbers are clustered in the middle and it's tapered off on the side. When it's tapered off on the side, when it's tapered off to the side here, it's called a tail. So we got a tail on both ends when it's tapered off to the side. And this is just displaying the shape. And you might have more numbers so you can see the bell curve a little bit more. But a bell curve or a normal distribution or an approximately normal, all of these mean the same thing, is where most of your numbers are clustered right here in the center. Okay? All right. Most of the numbers are clustered in the center. And they use that word clustered a lot. You might see it with the dot plot looks the same. Instead of using I'll use more points this time. Instead of using an X, they might use dots. And it's more, like I said, it's more symmetrical. It doesn't have to be a perfect, it doesn't have to be perfectly symmetrical, but when you look at it, you can tell that most of the numbers are in the center. Okay, when most of your numbers or data falls in the center, that's approximately normal, okay, or normal distribution, because most of the numbers are clustered in center. Think about grades. Most people fall in the C range, the average range, and C is in the middle. You have a few A's and B's, then you mostly have C's in your class, and then you might have a few D's and F's. That's a normal distribution. A skew to the right looks like this. The tail is on the right side. So it's tapered off to the right, but most of the numbers are clustered to the left. So we got our tail on the right. And I should have probably drew the graph first, right? Okay. Most of our numbers are clustered on the left side, but the tail is on the right. When the tail is on the right side and the numbers are pushed towards the left side, that's a skew to the right. This is a skew to the right. Okay, so the information or the numbers are clustered on the left side and the tail is on the right. This is a skew to the right. Okay, and you can do the dots the same way. Got your number line. Okay, and it doesn't have to be perfect. Okay, it doesn't have to be perfect. This is, even if I put one right here,